Can you hear me? Hello.
Yeah.
Uh, all
Hello?
right. Okay. Hello everyone. Good evening. My name is Muhammad Naufal Shauli Akbar. I'm an undergraduate student, and this is my colleges. Is Dr. Emma and Miss Febryanti Sthevanie. We are from Telkom University, Indonesia. Today, I will representing our research about visual feature and machine learning approach for Arabica green coffee bean. Like, um, this is the presentation we divide into four main content. And first one, introduction. Second, related works. The third is result. And the last one is the conclusion. Okay, our background is coffee has currently become one of the most popular beverages this day. Over the past 2 decades, the global coffee market have grown by more than 60%, and the total consumption is increasing from 98 million bags to 161 million bags in the crop year 2060-2070. And these two picture in the upper uh, is the main market of Asia, South and East Asia coffee market. That is Indonesia, Philippines, Vietnam, India, Korea, China, and Taiwan. And the coffee consumption in that region has grown faster at annual rate 6% on average. On the last picture, we see the egg main market in 2019. So this is our motivation. Coffee has selecting every single coffee bean. Coffee expert has selecting every single coffee bean by hand by they pack before they pack. This mechanism make process more prolonged, exhausting, inconsistency, and inaccuracy in the judgment process also can be different. However, to enable faster sorting and selecting the process, a machine or a system might be required, which is more expensive and challenging. So why we use computer vision to carry out the task? Computer vision can provide numerical data from shape, color, and textural. Also in the point, the Specialty Coffee Association established that to measure the quality of Arabica green coffee beans can examine by their color and texture using 300 grams of green coffee beans.
Mic on.
Uh, in approach with visual technique, there is two techniques. The first technique is using population of 300 grams coffee bean. This purpose is to classify the grade of the coffee bean population. And the second technique is using separated green coffee bean with each bean have a certain distance in the image. This purpose is to identify the defect or identify the coffee bean species. There is 900 RGB image as the input image with each image containing of 300 green coffee beans, and we classify the image into 5 grades from the best quality to the worst quality as shown in the stair database. Sorry, in the stair diagram. The best quality we have is specialty. The second grade is premium. The third grade is exchange. The fourth grade is below grade, and the last or the worst grade is on off grade. So this is the data set we have. This is 5 classes or 5 grade, and this is our proposed method. So the first one we need to input the image, then we resize and cropping for the pre-processing. We use the approach for the feature extraction. The first is color feature, and the second is the textural feature. For the color feature, we use color histogram, and for the textural feature, we use local binary pattern. From the color histogram, we only took 9 features. That is mean, median, modes from the each RGB of each pixel. And for the LBP, we took 256 feature from the histogram of the LBP. We combine it to build a feature concatenation. And for the classifier, we use the k-nearest neighbor or the KNN, also the random forest as the comparison. So this is how the LBP works. First thing first, we need to define the parameter P and R. The p-values, the number of the neighboring, and the r is distant neighboring. These are the example of the p parameters we use. From each image, we have every pixel. Uh, if the neighbor has a value higher or equal to the center, then the value is given is 1, and for the lowest value, we will given the value is 0. So the value will be compared clockwise to form a binary pattern that can be turned to decimal values. This is for the color histogram. We use the color histogram to approach the color feature of the image. Each pixel of the image will be calculating the R mean, G mean, B mean, and also for the median and modes. So will be 9 feature from the RGB. This is our classifier we use to classify it for comparison. The first one is random forest. Random forest is a combination tree predictor. Each tree depend on the random sample and have same distribution. To get classification result for the random forest need to gather decision from all the trees in the forest. And for the KNN is the most simple machine learning. KNN used to classify object databases on the closest distance with the training example. Uh, bef- Before we go to the classification phase, we need to split in the dataset first. The data set we split into 66 per 30/30 in ratio from all image into two type of data, that is data training and data testing. So in total, for data training there are 603, and for the data test is 297. This is our training and validation scenarios. There is a table factor length of the feature extraction. We use 9 factor from the color histogram. We use 256 from the LBP, and in total there are 265 concatenation features. This is our validation scenarios using K-fold stratified. The first scenario is using the LBP feature with the classifier. The second is using the color histogram feature with the classifier. And the third is using the concatenate feature with the classifier. And these two table here. The first one is random forest validation performance, and the second table is KNN validation performance. So from the both table, we found the best parameters for the testing phase, and the best parameter is using concatenated feature. From the table, we have 87% of the training accuracy using the random forest, and 81% of training accuracy using KNN with the stratified keyboard validation scenarios. So for the testing performance, there is two table. The table first using a random forest classifier, and the second is KNN classifier. For the random forest, we have 88% testing accuracy, and for the KNN, we have 80% of accuracy. And this is the result with a confusion matrix diagram. We use the confusion matrix to measure the system performance. And the first image on the right, the confusion matrix of the random forest, both premium grade and exchange grade having a lacking of performance from the image label as premium, 12 image predicted as exchange grade, and 8 image as exchange grade get predicted as premium. So meanwhile, for the KNN confusion matrix, not only the premium and exchange grade, also specialty have a lacking performance too. There is 7 image in the premium and 7 image in exchange grade. However, it seems premium and exchange grade is the where most misclassify occur, and similarity of the feature extraction value can make these things happen. So, in the conclusion, in this research, the concatenate feature for Arabica green coffee beans working, we achieve 86.56% average accuracy in the random forest and 80.8 accuracy with the KNN. However, some blurry image in the dataset can make inconsistency feature value from the other in the databases and could lead to a wrong prediction in the classification phases. Hopefully, our research can help the agricultural industry in the country with persistent consistency and innovation with the system. Maybe in the future work, we will be adding more pre-processing to enable the feature value represented better and increasing the number of datasets suggested to improve consistency of the system. In additional, using other machine learning or deep learning method are also needed as possible as comparison. Is there any question?
If you have attention, okay, I want to make a change. You have disposed the green
Okay.
coffee bean, green coffee bean by image disposal.
Sorry, what?
Um, and use two machine learning approach. This is random tree and k
Okay,
and yeah.
so the point is, why is the kind and the random forest, or I don't understand the first word of your question. Sorry, can you repeat it again?
Okay. The first is that you disclose the green coffee base
Okay,
by image.
all right.
Yes,
So we define green coffee bean by image because from
by image decoding.
what? Sorry.
And to yeah, I say you disclose the okay, organize the green coffee beans this level by image decoding
Uh,
method.
it was difficult or no? Is I think each coffee bean have a characteristic like there's the type defect level or just like different grade in the different grams. So if we use 300 grams coffee bean by the SGA rules, maybe if we gonna use the same Arabica, I think it's gonna be works with the system. But if we use the other species of the coffee bean, because our Robusta and Liberica have their own grades, maybe I don't know, never try it. So I think if we use under Arabica, it will be useful. So this is only for Arabica for the first Arabica, I think. But in the related works, they are using Robusta and they have a different grade. There is 7 grade for Robusta and I don't know about the Liberica. Just like it.
Okay, okay. Thank you.
Is there any question?
Okay, thank you.
Okay.
Um,
Thank you
you
very much for your time.
you asked excellent presentation. Thank you again.
Okay. Thank you
Bye.
for your time. Have a good weekend. Thank you.
Thank you. Next, we play C48 present.